If 980 kilojoules of energy are added to 6.2 liters of water at 291 Kelvin, what will the final temperature of the water be? All right, so this is another just straight heat problem. All right, Q equals mCp delta T. All right, so I'm trying to isolate the final temperature, which is in here. So the first thing that I'm going to do is I'm going to divide by mCp. All right, and then I also know that delta T is T final minus T initial. All right, so Q over mCp equals T final minus T initial. And I'm trying to find the final temperature. So I'm going to add T initial to both sides. All right, so my T final equals Q over mCp plus T initial. All right, so Q is 980 kilojoules over the mass, which is 6.2 liters of water. Okay, so here's something we got to do. All right, we need to find the mass in grams of water. So that sounds to me like it's another dimensional analysis. And something that's very important to remember this chapter is that the density of water is 1 gram per milliliter. Okay, super important that you remember this. So question mark grams H2O equals 6.2 liters of H2O. All right. Now, if I'm going to use grams per milliliter, this liter has to be in milliliters. So 1 liter per 10 to the third milliliters. Okay. And then I can do 1 gram over 1 milliliter. And that gives me 6.2 times 10 to the third grams. Okay. Which I can plug in for my mass of water, 6.2 times 10 to the third grams. All right, and then I need to find the specific heat of water, which I can go back and I can find on this table. Okay, liquid water, specific heat, 4.18 joules over grams degrees Celsius. Okay, now that's on the bottom and it's got funny units, so I'm going to put the 4.18 joules over grams, and then my unit of temperature is Kelvin, so I'm just going to use joules over grams times Kelvin, and that'll make my life a little bit easier. Okay? Now the other thing that I'm going to need to do, I see right away, is that all my kilograms and gramming, they don't, oh, this is supposed to be kilojoules, that's why. Huh. Oh boy. Kilojoules. No. Okay, there we go. Now we're good. All right. Oh, so what I was saying is the kilojoules and the joules don't go away. So we're going to have to do a little conversion here. So I'm going to put my joules on top and my kilojoules on the bottom. This is 10 to the third. This is 1. All right. Now my joules go away, my kilojoules go away, my grams go away, and I'm left with Kelvin. Okay, which is good because I'm not done yet. I need to add my initial temperature, 291 Kelvin. All right. Now, I just need to do a little bit of calculating. And so what I get is 329 Kelvin. Okay, and that is your final answer. You're going to go to the ones place because whatever you end up with here, you're adding these two numbers together. So it'll be using decimal places, which is to the ones.